All right, so for those of you guys that just walked in, we are going to be using a device of your choice today. So if you have a Chromebook, go ahead and pull that powered up. If you have a tablet, pull that out. I haven't tried this on a phone, so I don't know if it works on a phone. If you don't have a device with you today, I'm going to have you partner up with somebody who does have a device. But take just a minute to get your stuff powered up, and you need to go to our Canvas homepage. Head on over to our Canvas homepage. Lady's not here. Jude is not here. Sarah's here. Sarah is not here. Attica is not here. Brandon is here. 2, 3, 2, 3, and Maya's not here. Okay. Oh, yes, you are. I'm literally just taking attendance. All right. So where I need you guys to head, first of all, you're going to be on this page in your notes, and you're going to need this to record as you're working through the activity. If you want to work with a partner just because you want to work with a partner, that's perfectly fine as well. You do not have to do this independently. You can work with somebody. So Canvas homepage. Once you're on our homepage, you want to head on over to modules. And then you're going to scroll down to the second day where it says, what is a confidence level? This is what you're going to click on. So Tuesday, January 9th, what is a confidence level? All right. And then if you scroll down the page a little bit, you'll see where it has tasks 1, 2, and 3. And there's a link right here underneath task 1. That's what I need you guys to click on. It'll take you to a page that looks like this. Please let me know if you need me to go through that again. If it works from a phone, please let me know, because, again, it does. Cool. I was going to say, I haven't tried it on my phone, and I know sometimes it just doesn't. Give me a real quick thumbs up if you are on this page. Okay. Awesome. So now, everybody is here. If you look at the page in your notes, it says in this activity you will use, here's this applet, this is what I just sent you to learn what it means to say, we are 95% confident. You guys remember yesterday that was the beginning part of our sentence frame? We are 95% confident, or we are 90% confident that. And then we took it from there. So what I want you to do, you're going to set your population proportion to 0.5. So that's right here. Mine was already set at 0.5. Hopefully yours is as well. Set the population proportion. This first bar needs to be at 0.5. The confidence level, I want it set at 95%. So it should just say 95. So 0.5, 95. And then down here for the sample size, we're going to increase our sample size. Mine came up as being 20 as the default. We're going to set that all the way to 75. Is yours not slide over? Let me see. I wonder if maybe we can just tap over. Yeah, if you tap over, you can do it. If you're doing this from a tablet or a phone where you've got the touch, tap close to the center on this bar and it should move it for you. It doesn't really want to do the sliding, but if you tap about where it should go, you should be able to get it to move. Does everybody have those parameters set? Awesome. Okay. I want you to now click on this green button where it says sample. Oh, shoot, I just reset mine. You should notice that it puts a bar up here. Do you guys remember yesterday how we had our point estimate and then the margin of error? So the point estimate is going to be that gray dot, and the margin of error is extending to the left and to the right of that. So that's the bar on either end. All right? I want you now to tell me whether or not on yours that confidence interval captures what we set our true population proportion to be. We set ours at 0.5. So like on mine right here, is 0.5 captured by this bar? Yes. So I would answer yes to the first part of question number 2. Then I want you to repeat what you just did a total of 10 times. So you should have 9 more bars, 10 bars total, 10 confidence intervals total. And I want you to sketch them on here. And then I want you to write down how many of the intervals, how many out of those 10 captured that true proportion of 0.5. Yeah, do the same thing a total of 10 times. So you did it once for me already, do it 9 more. I want you to sketch all 10 bars on here. And then I want you to tell me how many of those intervals capture the true proportion. I'll come around if you guys are having any trouble with that. I'm going to give us about 3 minutes for that. As long as any part of that line touches 0.5. Yes, good question. As long as any part of that confidence interval, any part of that gray line, if it touches the 0.5, you would count it as being captured. Yeah, I do want you guys to sketch it on your page.
Yeah, write the equation.
Not necessarily. You don't have to write what the confidence interval is. You just want to get your sketches on there. We're going after big ideas right now. Good questions. So take right about 3 minutes to do that. Once you get finished with that part, if you're already done with that, I want you to hit the reset button. That's right down here, this big red button. So after you're done sketching your bars, we're going to go and do question number 3. So for this one, I want you to do 100 confidence intervals. So you're going to sample 25 4 times. That'll give you 100 on there. You don't have to sketch this part. So you'll reset and then hit sample 25 4 times. So you have 100 different confidence intervals on there. And I want you to tell me how many out of those 100 captured the true proportion. If you're curious, it will tell you what your percent hit is down here, so you don't necessarily have to count them all. So people should be finishing up question 2. How many out of your first 10 captured our true proportion? Then hit reset, and you're going to do a total of 100 confidence intervals. So you're going to sample 25 4 times. If you look right down here, do you see where it says your total is 100?
Yeah.
That tells you how many hit. So 92 so out of those 100.
Yeah.
Yes.
So
yeah, you don't have to count all those 100.
Okay.
If you look right above the reset key, it'll tell you how many of those. It's the hit out of the total. or sorry, percent hit. It'll give you percent hit and it'll give you total number hit out of your grand total. So you don't have to go through and count all of those. So, real quick, thumbs up if your first interval captured the true proportion of 0.5. If your very first interval that you did for me captured that true proportion of 0.5. Looks like we have quite a few of us there. I know when I did it on my own, it absolutely captured the true proportion. So here were my first 10. Anywhere the bar crosses 0.5, it is capturing it. I did have one that didn't get captured. So I had a 9 out of 10 with my first 10. I had a 90%. What were some numbers that you guys were getting for part 3 when you did it 100 times? What'd you get? 0.92? 0.92? 0.96? What'd you have? 0.97? 0.95? 0.92? Oh, you were working with her. Brandon, what was yours? Oh, you're still sketching that down. My apologies. What'd you have? Yes. 0.89? Okay. Ben, what'd you get for number 3, where you did 100 samples? Oh, you're still doing that one. What'd you get?
0.94.
0.94? 0.92? 0.91? 0.89? 0.94. When I did this, I got 0.94, 94 out of 100. What did we say our confidence level was?
95%.
95%. How many people got a number that was close to 95%? But not everybody hit it, right? Not every single one was a hit. I want you, play around on this thing again. Watch your confidence intervals, so go ahead and hit reset after you have your 100 on here. Watch what happens to the confidence intervals as you drag the confidence level from 95 up to 99. And then do some samples. What do you notice about those confidence intervals versus when we had it set at 95%? Write down any observations that you have underneath number 4. Then I want you to come in and do number 5. You're going to sample 100 times at 80%. And I want you to see what happens there. So take it up to 99, see what's going on with the bars, write down any observations that you have. Hit reset. And then do an 80% confidence interval 100 times. Coming. We could do it both ways, sorry. Here, you okay if I hit that?
Mm-hmm.
Okay. So let's do, you're right, I think I wrote the directions wrong. Okay, so there's 95. And I just reset it again. Let's do sample. Sample, and then let's take it up to here. Come on. It's being picky. There we go. Let's do another sample. And do that however many times. Just compare the bars between when it was 95% and when it's 99%.
Bars are closer to like these compared to this.
Compared to those, so you should have some bars here. You should go from like to the left and the right on those. What'd you guys notice when you changed your confidence level from 95 to 99?
The intervals got larger.
The intervals got larger. Why do you think that is? Yeah, if we extend those bars out longer, some of the ones that were misses before are now going to be hits. They're now going to capture that 0.5, even when that point estimate is decently far away. Not everyone's a hit, but by extending those bars out, we're going to have more of a chance of capturing that true proportion. So the intervals got wider. More of them capture our proportion of p equals 0.5. We need wider intervals in order to be more confident. Yesterday it was, I am 90% confident, or I am 95% confident that. Now I can say I'm 99% confident. I am pretty stinking sure that my interval here is going to capture the true proportion. So as my confidence level goes up, those bars got wider, so my margin of error is getting wider. That point estimate is still just a dot. But to make that confidence interval larger, those bars get longer, the margin of error gets larger.
I forgot my charger.
All right, come on in. What about an 80% confidence interval? Did you guys finish that one? What'd you say? They got shorter. When you did it 100 times, about how many were capturing the true proportion?
At 100%.
You got 100%? That is amazing. 80% confidence interval. What else did some people get, Anthony? You got 0.70? 0.78? 0.73? 0.73? 0.72, 0.73. What are you guys noticing about that number?
Pretty close to 80.
It's pretty close to 80. It's a lot closer to 80 than when we were at 95% confidence, right? So mine, I had 81 out of 100. Mine was an 81%. So interpreting our confidence levels. In that case, 80% about of those intervals captured the true proportion. That's what we mean when we say we are 80% confident, or we are 90% confident. We are 95% confident, 99% confident. If we take many samples and we calculate a confidence interval for each of those, we would expect about 80% of them to capture the true population proportion. Whatever that confidence interval is, that doesn't mean there's an 80% chance I captured the true proportion. That means if I were to use this methodology over and 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 over, whatever my confidence level is, that's roughly the percentage of those samples that would actually capture the true proportion. Does that distinction make sense? So it's not an 80% chance it's in there. It's 80% of repeated samples would actually capture the true proportion. Before we go on and look at number 6, what would be the advantage of a 99% confidence interval versus an 80% confidence interval? The size of the interval. 99% is going to be bigger or smaller than 80%? Bigger. It's going to be longer, it's going to be wider, we're going to have a larger margin of error. There's a better chance that I have captured that true proportion. So why would we ever want a confidence level that was smaller than 99%?
So maybe you want a smaller margin of error?
Want a smaller margin of error, would you say, Maya? Making it more. I've got my boundaries much closer together if we go with a smaller confidence level, smaller margin of error. If it's really important that I not have this huge interval, I want to try to get some precision here, I'm going to go with a lower confidence level. But when I do that, that increases the chance that I didn't actually catch the true proportion. I want you guys to see what happens when you adjust the sample size now. Change the sample size to 20 and do one interval. Then I want you to change it to 250. Don't hit reset in between. I want you to see both of these bars on the screen. Set your sample size at 20, do one sample. Then set your sample size to 250 and do one sample. Yeah, you can have the confidence level at 95%. Keep the confidence level the same for the two. The only thing that you want to be different between your two is the sample size here. What are you guys noticing? Changes sizes. Which one's bigger, the 20 or the 250? Which one? 20 is wider than 250? I don't know. Let's see. If I hit reset on mine, I set my sample size to 20. I do a sample. And then I set my sample size to 250. And I do a sample. What happened? Yeah, when it was 20, I've got a pretty wide bar there. It's capturing the true proportion of 0.5, right? When I go to a sample size of 250, am I still capturing that true proportion? What's happened to my margin of error? We've pulled it in tighter, right? But I'm still capturing the true proportion. I still have the same confidence level, but I'm narrowing those boundaries between the top and the bottom. I'm going to be able to get more precision without giving up my confidence level. I don't have to go with a lower confidence level if I increase my sample size. The interval is much narrower. As the sample size goes up, the variability of the sampling distribution goes down. So as n goes up, sample size goes up, the margin of error becomes smaller. We've reduced that variability when we increase our sample size. Does anybody need me to leave it up on this page a little bit longer? What'd you say? Let's flip it over and look at the back side. When we interpret a confidence level, I'm not sure how well the yellow printed on your page. Looks like it's decent enough-ish. If I'm explaining my confidence interval to someone, I say I am 95% confident that the interval from lower bound to upper bound captures the true population proportion of whatever my context is. If I'm asked to interpret what a confidence level means, what does it mean to say I'm 95% confident? What does it mean to say I'm 80% confident? If we take many, many, many samples and we calculate a confidence interval for each of those samples, about whatever percent of them will capture the true, whatever it is that I'm looking for on this problem. Your margin of error, as your confidence level goes up, your margin of error goes up. Confidence interval gets wider. As your sampling size goes up, the variability goes down, so the margin of error goes down. It gets tighter. Narrower interval. The margin of error already accounts for our sampling variability. That's why we calculate the point estimate, and then we've got a little bit above and a little bit below, right? Think of a normal curve. Think of the way that's shaped. The mean is right there in the center, but we know it's not weird to be a little bit to the left or a little bit to the right of that. That's what my confidence interval is showing me. It does not account for non-response bias, undercoverage bias, or response bias. Do you guys remember those from first semester? Some yeses. What's non-response bias?
You send it to someone and they just don't answer.
Right, it's like sending emails to a bunch of students and be like, I need your answer by Friday. Unless they make an announcement, unless you do it in your English class, you're like, yeah, no. What's undercoverage bias? Yeah, we don't get feedback from the entire, like a sampling of the entire group. Kind of like if you're calling landline phones and you want to find out what people that are middle-aged think about what have you. Most of those people don't have landlines anymore. What is response bias? Absolutely. It's where the wording of the question can influence someone's response to it. If you just say, do you think the mayor should resign? Or in light of the fact that the mayor's council has come out with a report that he has cheated on his taxes for the last 5 years, do you think the mayor should resign? Now we have more of a leading question. That's going to influence those responses. All right. Time to see how well we're doing with what we've got so far. I want you guys to do the check your understanding. Let's take, how many sections do we have in this one? 3, 4 questions. Let's do 8 minutes. I'll give you 2 minutes per question, and then we'll go over them together. So how would we interpret the 90% confidence level? What does it mean to say you are 90% confident? Ben? I love that interpretation. That's an interpretation of the confidence interval, which is great. That's what we did yesterday, and I absolutely want you guys to have that down. So, but that's an interpretation of what the interval is that the teacher came up with. I want to know, as someone who's never taken statistics before, I walk in, you're like, I am 95% confident that what Ben just said, and I look at you and I was like, what do you mean you're 90% confident? Lucy, what do you think?
Out of all the sample intervals, 90% of them hit the correct mean of Bishop students.
Yes, something along those lines, absolutely. So there does have to be some aspect of your interpretation of this that says, if I were to use this same sampling technique many, 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 many times, the idea is that you're doing it over and over and over. So if the gym teacher took many, many, many samples and they calculated a confidence interval for each one of those samples, roughly or approximately 90% of those would capture the true mean number of push-ups for students at this school. Make sure you get your context in there. Context is super important. What would happen to the length of the confidence level, to the length of the interval if the confidence level were increased to 99%? It's going to get wider. That margin of error is getting larger. Confidence interval gets wider, margin of error gets bigger. How does a 90% confidence interval based on a sample of 200 compare to the original 90% confidence interval when they just had 30 students? It would be narrower. Ben?
It would have much smaller variability to that of the original 90%.
Yes, I love both of those put together. It's going to be narrower. It's going to have much less variability. The margin of error is going to be smaller. And then we have our very last part here, part D. Describe one potential source of bias in this study that's not accounted for by the margin of error. Anthony. Yes, love it. Undercoverage, I would think, and I'm not saying that you couldn't come up with another correct answer to this, but I think the most obvious one right off the bat is undercoverage, and again, it is because he's just focusing on after-school athletes. Anybody who's not an after-school athlete didn't even have the opportunity to participate in this study. So his conclusions could really only be made about after-school athletes, not all students at this school. Does that make sense? That kind of gets back to the inference that we talked about first semester. Who can I say this about, and what can I conclude? Can I talk about cause and effect, or can I just talk about a relationship? What's the population that we pulled our sample from? Fantastic work today. We're done a little bit early, which they'll tell you that never happens. I never get done talking early. Homework is due tomorrow. You guys have a little bit of time to look over that. Get started on it if you'd like. It does need to be finished when you come in tomorrow, because then we'll grade that homework when we get here. I do my homework very similarly to the way Mrs. Ballatin does. Half the points come from completion. The other half come from doing your corrections and then submitting that. If you guys have any questions about anything that's on the homework, I am at your disposal for the next 6 minutes.